Hello everyone! So now let's proceed into our lesson for today, wherein we're going to discuss about the different basic set operations. At the end of this video, I know you can illustrate the union of sets, the intersection of sets, the difference of two sets, and the complement of sets. In arithmetic, numbers are processed to obtain another number through addition, subtraction, multiplication, or division. These processes are called the basic number operations. Basic operations are also done on a pair of sets to obtain a new set. In basic set operations, the concept of universal set is important. In any set operation, all the sets under investigation will likely be subsets of the universal set. Now class, what do we mean by universal set? When we say universal set, it is denoted by a capital letter. For instance, the set of fractions is a subset of the universal set of numbers. The Philippine population is a subset of the universal set of human population. So in discussing about the basic set operation, universal set is very important. Okay class, let us have the different basic set operations. The first basic set operations is the union of sets. When we say union of sets, it is the set whose elements are those which belongs to set A or to set B or to both sets. Another basic set operation is the intersection of sets. When we say intersection of sets, it is the set whose elements are common to set A and to set B. Next is the difference of sets. When we say difference of sets, it is the set whose elements belong to set A but which do not belong to set B. And the last one is the complement of sets. When we say complement of sets, it is the set whose elements are elements of the universal set that do not belong to set A. Okay class, let us have first the union of sets. For example, we let A consist of 2, 4, 6, and 8. We let B consist of 1, 3, 5, 7. And we let C consist of 3, 6, and 9. Now, let us find A union B. Remember, class, that to form the union of two sets, put all the elements of the two sets together in one set. So, we let have A union of B, wherein we have 2, 4, 6, 8, union 1, 3, 5, 7. Remember that when we say union of sets, it means it is the set whose elements are those which belong to set A or to set B or to both sets. So therefore, A union B is equals to 1, 2, 3, 4, 5, 7, and 8. Okay, another example about the union of sets. For example, we have B union C. So let us have all the elements. We have B union C is equals to 1, 3, 5, 7, union 3, 6, 9. So therefore, B union C is equals to 1, 3, 5, 6, 7, and 9. Okay, now class, let us have the intersection of sets. Remember that when we say intersection of sets, it is the set whose elements are common to set A and set B. So for example, we let A consist of 2, 4, 6, 8. Set B consists of 1, 3, 5, 7. Set C consists of 3, 6, 9. Now, let us find A intersection B. Okay, class. So, remember that we need to put all the elements. So, therefore, we have A intersection B is equivalent into 2, 4, 6, 8 intersection 1, 3, 5, and 7. So you will notice in our given that there is no element which is common in both set A and set B. Okay, another example. So we have B intersection C. So if we are going to write all the elements of set B and set C, it will becomes 1, 3, 5, 7 intersection 3, 6, 9. And you will notice in our given wherein the common element is 3. So therefore, B intersection C is equivalent into 3. Okay, now class, let us have the difference of sets. Remember that when we say difference of sets, it is the set whose elements belong to set A but which do not belong to set B. Okay, for example, we let set A consist of 2, 4, 6, and 8, while set B consists of 1, 3, 5, and 7, while set C consists of 3, 6, and 9. Okay, let us find A minus B. So in finding the difference of sets, we're going to put all down the elements. So we have A minus B is equals to the elements wherein we have 2, 4, 6, 8 minus 1, 3, 5, 7. And now you will notice in our given wherein the elements which belongs to set A but do not belong to set B are the elements which are 2, 4, 6, and 8. So therefore, A minus B is equivalent into 2, 4, 6, and 8. Another example, we have B minus C. Just like in example number 1, we're going to put down all the elements. So we have B minus C is equals to 1, 3, 5, 7 minus 3, 6, 9. Now, the elements that belongs to set A wherein does not belongs to set B are the elements 1, 5, 7. So therefore, B minus C is equivalent into 1, 5, and 7. Last example. For example, we have B minus A. So now, we have 1, 3, 5, 7 minus 2, 4, 6, 8. The elements that belongs to set B, which do not belongs to set A, are 1, 3, 5, 7. So therefore, B minus A is equivalent to 1, 3, 5, and 7. And that is the difference of sets. Okay, class, let us have the complement of sets. But remember that when we say complement of sets, these are the elements whose belongs to universal set but do not belongs to set A. For example, we have the universal set consists of 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, while set A consists of 1, 3, 5, 7, and 9, and set B consists of 2, 3, 5, and 7. Now, let us find A prime. So, remember that these are the elements that belongs to the universal set but do not belong to set A. So, therefore, A prime is equivalent into 0, 2, 4, 6, 8. Another example, we have B prime. So what are the elements that belongs to the universal set but do not belongs to the set B? So we have B prime is equals to 0, 1, 4, 6, 8, and 9. Another example. For example, we have A union B prime. So of course, in this given, we're going to have two basic set operation. The first thing that you're going to do is to look for the A union B. So we have 1, 3, 5, 7, 9, union 2, 3, 5, 7. And of course, A union B is equals to 1, 2, 3, 5, 7, and 9. So now, after that, we're going to look for the A union B prime. So what are the elements that belongs to the universal set but do not belongs to the A union B? So we have the elements such that 0, 4, 6, and 8. So therefore, A union B prime is equivalent into 0, 4, 6, and 8. Thank you, grade 7, for listening. Laus Deo.